Welcome to our first lesson in our maths series around grade 10 maths algebra. The slides that come from the website, which is listed in the links, start with a little activity around some occupations involving algebra. You can have a read through, you can pause the video and have a read through that one. There's another little video there which comes from another YouTube channel, which is a good task to start off with to get some ideas. There's a task around traffic flow that you can have a think about with some other people around how you design traffic systems to get where they're going. I'd encourage you to pause the video and do all those before you continue. The solution to all of those is basically algebra. Algebra is a tool that we can use to help something like traffic flow better. It's involved in a lot of computing things that helps us make control systems to control the traffic lights, and what we'll eventually do is control cars and so on, so cars can travel closer together and more cars can get through traffic lights. Humans just can't do that sort of thing. Here's another video that I encourage you to have a go at. Once again explains a little bit about algebra, and you can have a look at that guy who's now got glasses on. All right, so where are we? We're starting with weeks 1, and this stuff will cover weeks 1 as well as weeks 2 around linear equations. So what we're going to do is talk about solving equations. Why? Because it's the base of a lot of maths we do this year, and solving equations is how we solve problems in maths, which is how we solve problems in the real world. So quick bit of revision. If we start off with a sentence like this, 3 times x subtracted from y, how do we write that as a maths equation? You can pick the right answer if you know it, but we'll think about it this way. We're starting with an x that's listed there, but it says 3 times x, so 3 times x. And another way of writing that is 3x. And then it says this is subtracted from y. So this is subtracted from y. That's another way of saying we start with y and we're subtracting the 3x. So hence your right answer is B. Consider this expression. 5x plus 9. What is the variable? The variable is the thing that can change, the thing that we don't know. So that would be the x. The other number, that's a 5, that's a 9, we know what they are. This is an x, it can change, so it's a variable. The word coefficient, it's like it means it goes with. So what's the coefficient goes with the variable? It's the number that goes with that variable. So that would be the number 5, because the 5 goes with the x. It's 5 times x. And the constant is the other one that's left over, obviously. That must be the 9, because it's just a constant number. This 9 up here is always going to be 9, whereas the 5 changes depending on what the x is, because it's 5 times the x. So that's why the constant is the last one that's left over, the plus 9. Okay, what are like terms? Like terms are terms that are the same. Okay, so we can see that this we could think of as a's, but that's a number. They're a's because there's -4 of them. They're c's and they're a's. So if you think about it like that, the like terms should be relatively obvious. We've got the ones that have the a in there. So we've got the 3a, the -4a, and 1a there, which would be C. They're our like terms. It can't be A, for example, because that's a number, whereas the other ones are A's. These are like terms, but it's missing one of them. That's a number, that's an A. So they're different. They're not like terms. Which one's not linear? A linear equation, I didn't mention earlier, a linear is a straight line graph. If you draw a graph of it, it's going to be straight line. That's what linear means. We know an equation is a straight line if it just has a variable that is just the straight variable like the x's. This one here is not a linear graph because we have an x squared. That means it's going to be a curve when we graph it. But the ones that just have the straight x's are going to be linear graphs. So the one that's not linear is this one here, the odd one out, because it's got an x squared. All right, working out the values. So we've got 4x plus 7 equals 15. What we have here, we can kind of think about it according to our little table down here if we want to solve it. When we solve it, we want to end up with our x on his own, which means we have to get rid of this 4 and this 7, which means that on this side of the equal sign, I'm only going to have those x's, and all the numbers will be on that side of the equal sign. But if we think about this a slightly different way, if we start with our x and follow our order of operations, it's first multiplied by 4, because the x is then multiplied by the 4 you can see up there, and then the 7 is added on. Okay, so we've got our x, we're multiplying by 4, and then we're adding our 7. So we can work backwards and find the answer. So the opposite of plus 7 would be minus 7, and the opposite of times 4 would be divide by 4. Okay, so if we have our 15 and we subtract our 7 off, we're going to end up with 8. And if we then divide him by 4 like it says, x is going to equal 2, which is what this one shows us. So we have an 8 in there, and x equals our 2. And if we go the other way, following this track along the top, 2 times 4 is 8, 8 plus 7 gives us our 15. All right, if I were to write that out mathematically, I'll just do it here for you. Here's my equal sign. My 15 is not going to change to start with, but on this side I've got 4x plus 7. The first thing I'm going to do is I'm going to subtract 7, because 7 minus 7 is going to be 0. If I do it over there, I've got to do it over here, because that keeps everything equal like it says in the middle there. If I say that a different way, if I had, say, 2 equals 2, that's correct. If I have 2 minus 7, that all of a sudden doesn't work. I have to do the minus 7 over there to keep it equal. So that's why I'm doing it to both sides. So on the left hand side, all of this here cancels out and I'm only left with him. And on the right hand side, I can work that out. So on the left, I've got 4x equals, on the right, 15 minus 7 is my 8. Now I want to get rid of the 4 in front of the x there, so it's a 4 times x. The opposite of that was divide by, so I divide by 4, and the reason I do that is because these are basically going to cancel out, because 4 divided by 4 is 1, which is just 1 times x, which gives me x. So if I divide by 4 over there, I've got to do it here. 8 divided by 4 is 2. The orange writing there is a good sort of way to set it out. Notice I've tried to keep my equal signs lined up down the page there. Here's a few more. I'll just do a couple of them. So if I look at, say, number A, what I'm going to do is I'm going to plus 79 to that side. So I plus 79 to that side, and you can work out 153 plus 79. In C, I'm going to divide by the 6 because I've got 6 times the x, so I divide by 6, they cancel out. I've got to divide the 100 by 6, and you can work out what 100 divided by 6 equals. B is the same as A, it's a plus 46, so a minus 46. It's the same type of question. And in D, well, what I've got on the bottom here is a divide by 7. So what I want to do is multiply that by 7, and I've got to multiply that by 7. Okay, once again, why do I do that? This 7 on the top and the 7 on the bottom are going to cancel out and only leave me with the x. And you can work out what 19 times 7 is. And there's your answers there. 19 times 7 is 133. All right. You can check your answer by substituting into the final equation. Okay, so kind of like what I did when I did that very first example, the one with the circles on the page. I worked out that x was equal to 2, so therefore I put it back into the equation, substituted in to work out what it was. All right, when we do these equations, there's a definite sequence we go through. The first thing we deal with, so number one, the first thing we deal with is that constant on the end there. We get rid of him first. The next thing we deal with is the coefficient there. We get rid of him. Okay, there's various ways we can do it. Okay, in this part B here, the very first thing I'm going to do is I'm going to minus 4 to both sides, because that'll cancel him out. And I'll have -1 minus 4, or -5. I can get rid of the 3/2 by, I can do it a number of ways. One way of doing it is multiply everything by 2 and then divide everything by the 3. We can do it a few different ways like that. Let's have a look at this one. These ones are all relatively similar, and I'll show you why. I'll do parts C because it'll become obvious. I've got 4 outside of k plus 1 equals 3 outside of 6 minus k. All right, first thing I'm going to do is expand those brackets and get rid of them. So 4 times k is 4k, 4 times 1 is 4, 3 times 6, there's a minus sign, so minus 3 times k, 3k. All right, now what I'm going to do is I'm going to end up with all my variables on one side and all my numbers or constants on the other. So this is a minus 3k I've got over here. All right, so what I might do is I might plus 3k over there. So I've got a plus 3k over that side as well. So what does it work out to be? On the left hand side, 4k plus 3k is 7k plus 4, and 18 doesn't change, but 3k minus -3k plus 3k is going to be 0. All right, the next thing I'm going to do is get rid of my constant. I've got 7k plus 4 equals 18. It's the same as all the previous ones. The first one I did. So I'm going to subtract 4 to get rid of him, subtract 4. And what have I got? On the left, I've got 7k, and on the right, I've got 18 minus 4, which is 14. All right, now I want to get rid of the coefficient, the 7 there. It's a times by 7, so I'm going to divide by 7, divide by 7. So all I'm left with on the left is k, and on the right, I'm left with 2. 14 divided by 7 is 2. Okay, now a few things about this. When I did this very first step and expanded those brackets, this one here looked a lot like part B or part A. They're the same ones once I did that. Once I moved all my variables over to one side, take this step here, it looked like a very basic one that we started off with. Okay, and then it's the same from there. So when you do these ones up above, if you have a go at them, you can start by, say, if you take the 2a and you minus 2a from that side, you can minus 2a from that side. We do it that way because over on the left-hand side, 5a minus 2a is going to be 3a. If I had it gone the other way, I'd have 2a minus 5a, and now I've got negatives, negative 3a, and now I've got the negative to deal with. So I did that way so I didn't have the negative. So in part B, I'd probably subtract 2a from both sides. Okay, so I've got 6a minus 2a is 4a, it's a positive one, and that's a bit easier. All right, these ones start to get a little bit more challenging, and you can have a look at the text and see that there's multiple ways of doing it. I'll just show you a few little steps. One way that I find it's easy to think about it is to think, all right, let's look in part A. I've got 3 on the bottom of that fraction and 5 on the bottom of that. 3 times 5 is 15. So I'm going to have 15 as my common denominator. How do I do that? What I'm going to do is I'm going to multiply that side by the 5 and multiply that side by the 3. Now you can go around working out lowest common denominators and all that. The way I'm showing you can get a bit cumbersome sometimes, but it's the easiest way. So I'm going to multiply everything on the left by 5. So I've got 2x times 5, 1 times 5, and 3 times 5. What do I get? 2x times 5 is 10x, plus 1 times 5 is 5, over 15. And on the right, same. So 3 times x is 3x, minus 3 3s are 9. 5 times 3 is 15. And now I've got a common denominator. If I multiply this side by 15 and I multiply this side by 15, cancel out. Okay? And I'm left with, so my next line is 10x plus 5 equals 3x minus 9. And that's exactly the same as the one we did in the previous one. And you can work it out from there. All right. The yellow writing I'm writing there is not always essential to put down. It's just showing you how I'm getting my answers. When you work out this one, you should end up with x equals -2. Have a go at it. See if you get the same thing I did. Part B. Part B is a little bit different. Here's how we can think about this guy. Right, x over 3, we've got a -2, so that's like 2 over 1, because 2 divided by 1 is 2, and a 4 on the other side. If I multiply these numbers together, 3 times 1 times 4, it's basically 4 3s, is 12. 12 is going to be my common denominator. So what I'm effectively doing, what I did in the previous one is I had a 3 here, so this side I multiplied by 3. I had a 5 here, this one I times by 5. In this scenario, the only real number I've got on the left-hand side is a 3, so I'm going to times that side by 3, and I'm going to times this side by 4. Oops, I don't need that. But it doesn't kind of work that way. Let me just rewrite it so I can show you differently. Hang on, I've got the wrong color. I'm going to have x over 3 minus 2 equals x minus 1 over 4. Now what I'm going to do is multiply this one by 4, because 4 times 3 is going to give me 12. This one I'm going to times by 12 to give me a fraction of 12. And this one I'm going to times by 3. What does all that mean? Let me show you. So I'm going to end up with 4x over 12, because I went the x times the 4 and the 3 times the 4, a minus. So I'm going to have this as a fraction of 12, and 2 times 12 is 24. Because, so I went 2 times the 12 was the 24. But 24 divided by 12 is 2. And in my last one, I'm going to multiply by 3. So I'm going to have 3x minus 3 over 12. And the same deal. Multiply this side by 12 times 12. And on the next line, I get rid of the fractions. Like that. Okay, and that's the same as the ones I did on the previous slide. You can work them out. And once all that goes through the wash, you end up with x equals 21. There we go. See if you work it out. See if between there and there you get the right answer. Once again, the orange writing is probably the essential stuff to write down, plus the steps I missed. The other colours I just did to show you what I was doing. All right, one more quick example. Example 4. Write an equation for the following and solve it to find the unknown numbers. The sum of 3 consecutive numbers is 21. Okay, let's call these numbers. The first one I'm going to call x. The next one must be x plus 1. And the next one must be x plus 2. We don't know what x is yet. If x is, say, 5, the next number must be 6, which is exactly the same as saying x plus 1. The next one must be 7, which is x plus 2. Okay? All right. So it says the sum of these numbers is 21. So if I add them all up, it's going to be 21. So I've got x plus 1 plus x plus 2 is 21. All right, we can then simplify that. How many x's have I got? I've got 3 of them, so it's 3x. And the numbers, there's a 2 and there's a 1, so 2 plus 1 is 3. And that's the same as all the rest of them now. You can work that out and work out that x equals 6. Okay, so if I found out that x equals 6, therefore the numbers are the consecutive numbers. Well, if x is 6, the next one is 7 and the next one is 8. 6, 7 and 8. You can substitute this back in to work out if that works. What I mean by that is you have this equation here. If you've worked out that x equals 6, you have 6 plus 1 plus 6 plus 2 equals 21, and see that it actually works out. Okay, right. With a lot of these ones, you've got this worded stuff up the top here that makes it look hard. All you've got to do is translate it into some sort of math problem. Once you do your first simplification step, you usually end up at a number sentence just a bit like this one, this sort of equation, and then it's just straightforward to work out. Have a go at some questions I'll show you in a minute. I just want to point out that in the Pearson textbook you have fluency questions that it starts with, usually your basic up to C level type questions. The understanding is some C questions moving towards a B sort of rating, like I want to get a B overall. The reasoning questions come next, and they're heading towards an A rating. And obviously open-ended questions are the much harder ones, where you're definitely at the top of an A rating if you can do those questions. You'll see what I mean when you have a look at the questions. So have a look at exercise 4.1. Have a go at the one I've pointed out there with the arrows, the middle column, those ones in the purple column there. Have a go at doing those questions. Okay, thanks for coming.